All right, welcome everyone. So my name is David Rodriguez. I am an astronomical data scientist at the Mikulski Archive for Space Telescopes, or MAST, as you can see here, and I work at the Space Telescope Science Institute. So today it's my pleasure to talk to you about ExoMast, and as was briefly mentioned, I will sort of go over a brief presentation, a sort of walkthrough through what ExoMast has to offer, and then in the later half of the session, we can have a Q&A if you have any questions or you have any feedback that you would like to give. Before I jump in, I do want to point out that we do have a Contact Us button down here at the bottom of the interface. So we do encourage people to use ExoMast, certainly for their research and teaching material. And we encourage people to send us feedback. If you are using this and you have any issues or you have any suggestions, or perhaps you're an educator and you have produced notebooks or tutorials or workshops or worksheets or anything of that nature, we would be very happy to see that and perhaps help in any way that we can. So without further ado, let's jump right in. ExoMast. So from the name, you can probably guess that ExoMast is all about exploring extrasolar planets. And we just had a very interesting plenary talk this morning. So it's very well timed that we talk about how to search for exoplanets right after hearing some motivating talk about exoplanet science in general. So when you go to this interface, the main thing that you'll notice is a very big search bar. There is also an orange button here to see the table of exoplanets. I will touch on that towards the end of my presentation. Let's actually focus on the search bar itself. So here you would type in the name of whatever planet you are interested in. And as you can see as I'm typing, you see that there is some auto-completion going on. Special characters like dashes and spaces are not required. I'm going to go ahead and look at HAT P11b, in particular because I know that one has a lot of very interesting data to best show off our interface. So I've clicked HAT P11b and some of our information is being loaded, and there's a lot of things going on the screen right now. So let me walk you through the various aspects. On the left, in this gray area, is the planet information. So it's the planet metadata provided from a variety of sources. And when you hover over a particular thing, you'll see the description of what exactly you're looking at, as well as links to exactly where that data is coming from. So this is useful in case you're curious as to, all right, who measured the transit duration for HAT P11, for example. This data that's being shown here for now is from the STScI page, and this is a link, so you can go and click this and you will be sent to the NASA Exoplanet Archive information for HAT P11. They have some separate webinars, so you'll be able to see more in depth of the NASA Exoplanet Archive there. For now, let's focus on ExoMast. And if for some reason you don't want to see the information from NextSci, you can use this drop-down menu to select some other source of the data. For example, you may be interested in the test data validation report information for HAT P11b, and that's what's now being shown here. So you can see that the transit duration is now coming from a separate source, At the bottom of the page, you'll see a table of results. These results are actually the search against the MAST multi-mission archive. So these come from, this is showing the observations for that particular target as searched through by the right ascension and declination for everything that we have in MAST. So this includes HST, GALEX, it includes Kepler data, it includes test data, and eventually will include JWST data as well. The columns you see here are filterable and sortable. So for example, let's say you're interested in the test data, you could go here at the edge and type in tests, press enter, and now we are seeing just test results for this particular system. Towards the right in orange, these are links in case you want to download the data for this particular observation. And for these two cases, this is the test FFI data. This is the sector data, the full frame images. And you'll see there's separate buttons called FFI cutout. If you click this, you will be sent to the test cut page where you can make a cutout. Instead of downloading the entire sector's worth of data, you can just download a smaller cutout centered around this particular object. The right ascension and declination here are being populated from ExoMast, so this is a convenience feature. And when I click refresh sectors, you should be able to see that this is in sector 14 and sector 15, which is what you were seeing here in the table of results. Let me go ahead and clear that filter. And now we can talk about the main panel of information here. These are a variety of quick look tools to help you explore the data available for the system and the properties of that data. So which ones appear will depend on a per planet basis. HAT-P11, the reason why I chose it is because it has a lot of different tabs that we can explore. Some other planets may just have one or two. Most cases though, we'll start at the data coverage. This is a graphical representation of the table you are seeing below. So this is the same set of observations, but they are folded onto the phase of the transiting planet. So in this case, we know HAT-P11 has a particular period with a particular duration, and we have folded the data here. So you can see this is the transit window. This is when the planet is transiting in front of its star. There's also an eclipse window at the edges where the planet is completely behind the star, and everything else is when the planet is off to the side. And so this can be very useful if you are specifically looking for data during the transit. And if you click something like, for example, HST, let's give it a few seconds, you can see it broke it down by the variety of HST instruments that have data here. And I can select the ones I want. I can select the data during the transit. And now below, this table has been filtered to just results that I have selected here. So now it's much more easier for me to download the particular STS observations that I want that happened during the transit. Let me go back and show all of the results again. The next two tabs are light curves. I'm just going to show you the test light curve, but the Kepler light curve pretty much looks the same. This is an interesting system that is in the Kepler field and has also data from tests, so it's very interesting. You can see that we have a variety of quick look plots that have been automatically generated from the data itself, and there's a variety of interactive tools here. So I can, for example, zoom into the transit and explore it in more detail, and I can save this particular image. If I want the actual data itself, there are buttons here for your convenience to just download the data validation time series for this particular objects. And you can always see documentation if you want to learn more about how some of these light curves were produced. The next tab is transmission spectra. We only have transmission spectra for a handful of systems, but when we do, they'll appear here. And you can see how the transit depth changes as a function of wavelengths. This particular set of data comes from a paper by Freyne et al. From 2014. And we provide links so you can download a text file with the data points that we have plotted here, as well as links to the abstract if you just want to go to AAS and download the paper and examine it in more detail. And this plot is also interactive in case you want to zoom in and out. The next tab are the related links. So this is a variety of links that we feel are useful to have when exploring exoplanet data. You'll see, for example, curl scripts in case you want to download all of the test data, links to ADS in case you want to look for papers for this particular systems, links to the exoplanet follow-up observations from NextSci, and the test data validation reports when available. And this just is handy links for you to download, for example, just a PDF. Now you can also find that down here when filtering out and searching for test data. This just provides a very handy look at, a very quick look at where the data is. The last tab is the JWST target visibility. So This can be a bit of a complicated plot, but it is generated as part of the exoplanet characterization toolkit. And this gives you an idea of, let's say you want to create a JWST proposal, you want to use the nearest instrument, and you're trying to find out, okay, what position angle do I need for a particular date? You can see the information as you hover over this tool. If you do click this link here for contamination overlap, you will be sent to ExoCTK, the Exoplanet Characterization Toolkit, which has a lot more description as to the plot you were just looking at. And this information is populated for you, so you already have the target in mind that you can select the type of instrument and mode that you want to create a visibility plot for. There's also some additional information here. This is the relative signal to noise ratio for a variety of emission and transmission values across a handful of wavelengths. This just gives you an idea of how strong the transit will be such that you can make a transmission spectrum. And a different way of exploring this information is actually to look at the exoplanet atmosphere observability table. This was that link at the very beginning. If I go, for example, to the main ExoMast page, this link here sends you to the exoplanet atmosphere observability table. And this is a table that has a subset of the columns of ExoMast, focusing on these relative signals noise ratios relative to HD209 458B. So if you know how much exposure time you need to get a good spectrum for that, you can judge how much of an exposure time you need for your particular system. As you just saw, these are all clickable and sortable. So I can decide based on the duration of the transit or the strengths, the expected strengths of my signal. And you can query and filter down this table, so you can add conditions and you can select exactly what you want to search for. You can also remove conditions, and you can choose an entirely different subset of the data. So right now we're just seeing the NextSci data, but let's say you want to see the TOI data with no filters. I can click search, and now this is showing me all of the test objects of interest, nearly 1,800. That we have available with all of their information. And there is a link here to export the table to a variety of formats. On the left, these are actually links. So let's say you're very interested in this particular TOI that has a very large 5 micron emission signal to noise ratio. You can click this and you'll be sent back to ExoMast for that specific system. And so you can explore it in more detail and you can decide, oh, let's look at the light curve and let's look at some of the information available for that. This looks very triangular. This might not be a legitimate planet. This could be an eclipsing binary or something of that sort. But you can judge that accordingly based on what you're seeing here. You can see the ExoFob to see if there's any additional observations that other people have performed. And of course, you can download the data and look at it yourself. The last thing I want to point out for ExoMast is that we have as well a link here to the API documentation. So clicking that will give you an idea of how to make calls to our various services to get things like resolve the exoplanet names, get the light curves, and do queries of that nature. So in case you don't want to use the UI, but you would rather do it programmatically, this is an option that's available for you. And it's 11:47, so I will be wrapping up my part of the talk. Thank you very much for attending, and now I will open up the floor for questions.